welcome to the Journey Chez Chem. And number one, you have to determine what type of bonding. And there's only two types of bonding. It's either covalent or ionic. And so therefore, you should look back into your notes to determine which types of elements form ionic and covalent bonds. Well, you do the best you can, and I'll see you in a moment. Number 1A is water, and water is composed of hydrogen and oxygen, and those are both nonmetals, and therefore it forms a covalent bond. And also, you would remember that we did draw the shape of that molecule. It is covalent. In B, sodium iodide is a metal with a nonmetal, and that is a salt, and all salts are ionic. Oxygen is a diatomic molecule, and oxygen is a nonmetal, therefore it is a covalent bond. Copper 2 sulfate is a metal with a polyatomic ion, and therefore it is ionic, and it is an ionic bond. Number 2 asks for the differences between ammonia and water. Therefore, the best thing to do would be to write the formulas and then draw the shapes. Ammonia is NH3. That's a funny 3. Nitrogen has 5 dots. And hydrogen has 1. And that's how we draw that shape. It is trigonal pyramidal. And it has 107 degrees. And water is H2O. And in this case, we know that the oxygen is in the middle. And therefore, we have 1, 2, 3, 4, 5, 6 outer electrons for oxygen, and hydrogen has 1. And therefore we get an octet. And it is a bent 2 with a 105 degree. The differences, once we draw the shapes, are very clear. In ammonia, we have 1 lone pair, and in water, we have 2 lone pairs. Therefore, we have 2 different shapes. We have a trigonal pyramidal and a bent 2. And also, the lone pairs, because water has 2 lone pairs, it has much greater repulsion, causing the angle to be smaller. Those are a lot of differences. And also, I wanted to show you again, because I know you love balloons, so I thought I'd show you this. When I have the 4, and these 2 pink ones, the 2 pink ones are my lone pairs. And my purple ones are my shared pairs, or my bond pairs. And you'll notice that no matter how I turn it, they are on the same side. No matter how I turn this molecule around. And if I tried to squeeze it so that they were in a line, it would be very unstable. It just wouldn't like it. And it's not going to do what it doesn't like. It just won't. So I could try it, but it just won't stay. It's very obstinate that way. So you see, it just bounces right back and it just won't work. So there you have it. Those 2 lone pairs are on one side, even though in a 2-dimensional drawing it has 1 on top and 1 on the bottom, and it seems like it will cancel, but they don't cancel. Now they both have hydrogen bonding, because you'll recall that hydrogen bonding occurs between hydrogen and nitrogen, oxygen, fluorine, the NOFs. And so both of them have hydrogen bonding. That would be a common factor that would be between both of them. Now, today you have a review worksheet to work on for tomorrow, and then the following day there'll be an assessment, and I know that you'll be ready for that assessment. We've had lots of practice and lots of diagrams and lots of warm-ups, and it's been so much fun. I love shapes and I love playing with balloons, and hopefully you play with some balloons too at home. Therefore, I will allow you the rest of your time to work on that project, the review worksheet, and we'll talk to you tomorrow. Bye! Thank you.